Space mining is quickly emerging as one of the most exciting frontiers in technology and resource extraction. The concept of harvesting resources from asteroids, which contain metals and minerals that are rare on Earth, has the potential to reshape industries and accelerate space exploration. China has made substantial strides in this area, positioning itself as a global leader in space mining. With a rapidly growing space program and a clear vision for the future, China is investing heavily in the development of technologies and strategies for asteroid mining. The resources found in asteroids, such as platinum, gold, and rare earth elements, highly valuable and could revolutionize the global economy. For China, space mining is not just about economic growth, it is part of a broader vision to dominate space exploration and establish a sustainable presence beyond Earth. As the world looks on, China's ambitious plans could change the landscape of both space exploration and Earth's resource industries, marking the beginning of a new era where space mining becomes a key part of humanity's future. Asteroids are incredibly rich in valuable resources, making them prime targets for mining. Many asteroids contain metals such as platinum, gold, and other rare earth elements, which are crucial for technology manufacturing, renewable energy systems, and even space exploration infrastructure. These metals are becoming increasingly scarce on Earth, driving up their value. Space mining offers a potential solution to this shortage by tapping into extraterrestrial resources that are far beyond Earth's reach. For instance, the asteroid 16 Psyche, one of the largest in the asteroid belt, is estimated to contain over $10,000 quadrillion worth of metals, including significant amounts of iron, nickel, and platinum. If mined, these resources could be used to support Earth's industries or to fuel future space missions. The economic benefits of asteroid mining are immense, as the global demand for these rare materials continues to rise. China's interest in this field is not only driven by the promise of economic returns but also by the potential to gain a strategic advantage in the global race for space resources, which could give the country an unprecedented level of control over critical materials. China's space mining goals are ambitious and align with its broader strategy to become a dominant player in space exploration. China has outlined plans to begin mining asteroids by 2025, with the long-term goal of creating a self-sustaining space economy. These plans are backed by the country's growing capabilities in space exploration, supported by massive government investments in space technology. China's space program has made tremendous progress in recent years, with missions to the Moon, Mars, and even the construction of its own space station, Tiangong. The next logical step in this progression is space mining, and China is positioning itself to be the first country to make it a reality. To achieve this, China has been working on the development of robotic spacecraft capable of traveling to asteroids, extracting resources, and returning them to Earth or using them in space. These efforts are supported by China's National Space Administration, CNSA, which has been working to create the infrastructure needed to make space mining viable, including advanced propulsion systems, robotic technologies, and autonomous operations in deep space. To achieve its goals in space mining, China must overcome a number of technological challenges. One of the biggest hurdles is the ability to travel to and land on asteroids, which requires precise navigation and propulsion systems capable of operating in the harsh environment of space. China has been developing advanced space vehicles, including robotic spacecraft and landers, that can safely transport mining equipment to asteroids. The extraction of resources from asteroids presents additional challenges, as these celestial bodies have weak gravity and uneven surfaces, making it difficult to land and anchor mining equipment. To address these challenges, Chinese scientists are working on developing specialized robotic mining systems that can function autonomously in space, equipped with the ability to drill into asteroids, collect resources, and store them for transport back to Earth or use in space. These innovations are critical for the success of China's space mining ambitions, as they will enable the country to overcome the unique challenges of asteroid mining and make it a commercially viable industry. China is already launching space missions that support its asteroid mining objectives. In 2020, China's Chang'e 5 mission successfully brought back lunar samples from the Moon, marking the first time in more than 40 years that a country had retrieved material from another celestial body. This mission not only demonstrated China's advanced space capabilities but also laid the groundwork for future asteroid missions. China is also developing a spacecraft capable of landing on asteroids, with missions planned to explore and collect resources from objects in the asteroid belt. These spacecraft will be equipped with advanced robotic systems designed to extract valuable minerals from the surface of asteroids. China's space program has already made significant strides with its lunar and Mars exploration missions, and the lessons learned from these endeavors will be critical for the country's future success in space mining. As China continues to develop its capabilities in space exploration, it is positioning itself to become a global leader in the emerging field of asteroid mining. The economic potential of asteroid mining is enormous. The metals and rare earth elements found in asteroids are incredibly valuable, and their extraction could help alleviate Earth's dependence on dwindling resources. China is well positioned to take advantage of these resources, with its growing manufacturing sector that relies heavily on rare earth elements. The mining of asteroids could provide a steady supply of these essential materials, potentially lowering costs for industries such as electronics, renewable energy, and electric vehicles. In addition to supporting Earth's industries, the resources extracted from asteroids could also be used to fuel space exploration. For instance, mining asteroids for fuel could support long-term space missions, including crewed missions to Mars, space colonization efforts, and the establishment of lunar bases. The economic benefits of asteroid mining could therefore extend far beyond Earth, enabling the creation of a space economy that supports human exploration and habitation beyond our planet. China's approach to space resource development is both strategic and forward-thinking. The country has built a robust space exploration infrastructure, which includes advanced spacecraft, powerful rockets, and cutting-edge technologies. This infrastructure provides China with the tools it needs to establish a foothold in space mining. China's space mining strategy is not just about extracting resources, it is part of a larger vision to create a sustainable space economy. The development of space mining technologies will help China reduce its reliance on Earth's resources, enabling future space missions to be self-sustaining. Moreover, China's growing space capabilities allow it to establish partnerships with other countries and private companies in the field of space resource development. As China continues to develop its space program, the country is laying the foundation for the future of space exploration, one that relies on the use of extraterrestrial resources to fuel human expansion into the cosmos. While space mining offers tremendous opportunities, it also raises significant ethical and environmental concerns. One of the biggest ethical questions is how to regulate the exploitation of space resources. Without international agreements on the ownership and use of extraterrestrial resources, there is a risk of space becoming a new frontier for exploitation, with nations and corporations racing to claim resources without regard for environmental sustainability or the rights of future generations. Additionally, there are concerns about the potential for space mining to disrupt the natural environment of asteroids and other celestial bodies. While asteroids are uninhabited, they are still part of the larger cosmic ecosystem, and mining them could have unintended consequences. There are also concerns about the environmental impact of mining operations on Earth, as space mining could lead to the creation of space debris and the potential for conflicts over resource ownership. These challenges must be addressed through international cooperation and the development of regulations that ensure space mining is conducted responsibly and ethically. China's space mining efforts could have a profound impact on future space exploration and the global economy. By tapping into the resources of asteroids, China can support the development of a sustainable space economy and reduce the dependence on Earth's limited resources. Moreover, space mining has the potential to revolutionize industries such as manufacturing, energy, and technology, providing new materials and energy sources that can power future advancements. As China continues to make progress in space mining, it will not only shape the future of space exploration but also influence global economic and geopolitical dynamics. Space mining is no longer a distant dream, it is becoming a reality, and China is leading the charge in this groundbreaking field. As we look to the future, the potential for asteroid mining to transform industries and fuel space exploration is limitless. China's ambitious plans for space mining could set the stage for a new era of technological progress, opening the door to a future where resources are no longer limited by Earth's constraints.